Hi everyone, my name is Joe Scar. We're going to take a look at how to build a 3D noise field with TP from scratch. And I'm going to go ahead and start off. We're going to name our first dynamic set on our first group system, just so that we can have a nice clean container to work inside. Then we're going to go ahead and first thing we're going to do is going to create a volume of particles in order to visualize the force, kind of like force viewer. And so we'll call this, points, and then this would be vectors. So we'll birth points first, and so we need to build a cube procedurally, so we're going to need some iterators. And we'll just go ahead and grab these, one for X, Y, Z, and then we're also, of course, going to want to control when this fires, so we'll use a Boolean connected to an egg timer, since that gives us a nice single switch that can occur whenever we need it to. Boom. Reached. And of course we're going to need a position born. We're going to birth a point per call. And lifespan, we'll set it really long. And of course, because this is set to single, it's only going to fire once, really. Now we're going to need to control the grid size. And so we're going to take our number normalize into each of actually we'll take them into here. We're going to do this because we want to set up a multiplier for the overall grid size as well. Interesting thing about this is, so if I want my overall units to be 100 basically, if we're going to use the multiply on point 3, we have to set that to 1. So this is going to come in as 100 on all 3 axes, and then those are going to get multiplied against, that vector gets multiplied against the normalized values, which will be from 0 to 1, so 0 to 100. Okay, so that looks pretty good. Let's go ahead and see if it works. Little tip, I like to name these the name of the group. That way it's easy to debug and visualize when you're looking inside the rule. Okay, well, we got somebody there. Let's go edit on the fly off because we want to see the results as we modify this. So what do we have? We've got a pistol shot per call. These iterators are all coming in here. We need to control the iteration amount. Let's say 10. Okay, so we get a nice grid there. Let's go ahead and maybe we'll do 20, and we'll switch our size here. Let's go 200 units. Okay. Name our rule to stay clean and organized. Okay. Excuse me. So we'll make our points kind of a light blue color so it's easy to see through. We'll make them dots, not cached. Then vectors, we'll go ahead and make green. And we want them to show us drops, because the first thing we're going to do is visualize our 3D noise. So to do this, we are going to have the points birth what's called marker or vectors. It's up here. This is still forcing display. We'll set our first frame simulation to 1, so we have a safe frame on the first frame. Can't see those points at all now. Kind of, that's better. Get it back to this. Still, that's pretty faint. Let's go more of a yellowish orange. There we go. Alright, so what we're going to do is have the points give birth to some vector particles. We're going to give them a lifespan of 0 because we want them to just live once and show us a direction that the noise field is generating. For this, we're going to want to send our vectors, give them velocity in a certain direction based on the noise field. So let's go ahead and build the noise field. Noise field's pretty easy. This is the great thing about thinking particles, is it gives us the components, the small components we need in order to build bigger systems. We don't always need the developer to create things for us, only when it really makes sense. So I'm going to use a smoke texture. Only problem with smoke is that it's hard to get kind of super bright values. So we're going to go ahead and wrap that inside of an output. And keep that. Okay, so now we get greater variation in the value of the texture. And we're going to go ahead and we'll drop this into the text map. So we're also going to want 2 more of those. We'll call this smoke 2, and I'll call this smoke 3. And of course we're going to want to modify some of these values so it's not all the same. So we get different noise in different axes. You can have the same noise in each axis if you want. Alright, so there's our first noise. Let's make sure we call these by name so that we can see them in here. We're going to go ahead and duplicate this a few times. We'll get the second noise, smoke 2 there, and smoke 3. So smoke 1, this is still showing up as map 1 there. Smoke 2, smoke 3, great. So what we want to do is we want to take the surface position, which is really kind of the world position of our points, and then we want to convert those, we want to convert the value of the color into a positive or negative value that we're going to use to control the vector direction. So we're going to have to split out the color into its value, and then we need to here's what we want. If the value is white, we want the direction value to be 1, or the magnitude of the vector to be 1, and if the color value is black, then we want the vector magnitude to be -1. This way we get plus or minus in each direction. So all we have to do here is we're going to take the color value from 0 to 1. It's going to output from -1 to 1. And we'll feed this into a 0.3. And we'll just go ahead and duplicate the rest of this. And vectors are just our debug group. We're just using them to see which direction it goes. Let's go ahead and plug this into direction like this. Okay. So let's see what we get. Well, they're not moving very fast. In fact, they're not moving at all. So let's go ahead and give them some. There we go. Get some nice vectors going on. And it's a little hard to see, but you can tell that all these are going different directions. And I'm going to show you something else that's really handy right now, which is texture control using TP. So the requirement for this, though, is that it has to be a material on an object. So we'll go ahead and convert these into, drop these maps in materials. And of course, we always use instance so that there is a connection between them. Let's drop this as the first. This is the second smoke, and this will be the third smoke. And again, Thinking Particles has given us a very useful tool called paramblock, which we can use to access an object in the scene and access anything connected to it, basically. And in this case, we're going to go ahead and use the smoke map, and let's control, for instance, the size. And we'll duplicate these. Edit on the fly is a little bit dangerous, it seems, sometimes, to make things a little more prone to crashing, so we're going to go ahead and turn that off. Rather, we're going to turn edit on the fly on. I know that's a little confusing. So here, let's do 3D noise. You can see I've already been doing some examples. MX16, TP64X, and we'll call this version 5, just because we're going to go nice and simple and fast. So we've got param block. We'll call this rule texture control. And the param block, right now this has all Geo1 picked, so let's update those objects. And of course it resets the inputs, so we have to refine those. And boom. Let's get the size. The other thing we can do is we could also control the phase if we wanted to, so we could actually have TP change. We'll look at how to do that, how to control the phase over time. That's pretty easy. For one, we'll need size. Next, let's get phase. This one's almost set. Let's get phase as well. Okay, so we've got these three, and we'll go ahead, and of course right now this is going to force them all to use the same size, but their phases are different. So if we set this, and we'll turn edit on the fly back on so we can, off, so we can see the result as we change it. And so now, if we control our texture size, you can see our little things shaking around there, and you can kind of see right in here where the noise field is it's pretty decent size, and so you get a nice smooth blend between the values. That's a little too chaotic. Somewhere around in here is pretty nice. Okay, so that's our texture control. This is kind of a debug rule, so we're just going to put a little pound sign in front of that. So there's our vectors. And what we can do is we kind of need to debug now, and we'll show having a particle. We're going to birth particle off that, put our texture control down here. Alright, so now we want to, we don't need our vectors really, they're just to visualize that the noise field is pointing in different directions. Let's go ahead and see the effect of shooting a particle through this noise field. And of course right now our iterations are set up only in this cube, but you should know that our surface position, because it's tied to this texture like this, goes all through world space. And so go ahead and just copy this whole block, turn off the birth vectors, turn edit on the fly back on, and now we're going to birth a particle, new particle. We'll call this tester. Tester, nice bright purple. Set it as drops, and let's use the node to control where it's born. Add a little helper, and boom, let's just go ahead and birth. Let's birth a stream, sure. Let's set the lifespan pretty long, and speed 100 for now. Direction, let's go up, and maybe say 10 degrees of variation. Of course, put those in the right group, and now I need to go ahead, let's make sure this is picked. Half the time these things aren't picked, and you're wondering why it's not working. Now let's go ahead and ask tester to look at, and here's one of the things that you can do with TP as well, of course, is drop this into a sub kind of dynamic set so it's easier to organize, so that way you can create common inputs for these. Right, somehow I ended up with an extra one. Go. So this, of course, is a vector coming from surface position, so it's automatically going to grab the position for the particle when we connect it to the particle output. Vector inputs always grab the position, at least when you connect it to particle like that. Alright, so we're going to go ahead then and also our noise not really being used, but let's just see. Okay, so we get some of these coming up here. Let's move this. What I want to do, remember our grid here doesn't really matter. All these points as well, we can turn that off. Actually, we might as well go ahead and put that into its own rule for debugging purposes. Call this, what, show grid or something. And let's birth our tester. I know it seems a little bit tiring or boring to name everything like this all the time, but believe me, as the system gets more and more complex, it's better and easier to navigate. So what we're going to do is we're going to have this particle look at its age, and if its age is, say, over 10 or something, we're going to go ahead and have it be affected by the noise, because we want to give it, and remember, the points aren't there anymore. The noise field exists in space completely. So we'll go ahead and have it begin to be affected, say, after age 20. So they'll fly straight for a while, and then they're going to get some vector direction. Now, I know what's going to happen as soon as we do this. We're going to go ahead and expose our direction here from the noise field. It's going to be too strong, most likely. And so our particles, yeah, you can see they just, right now, they basically get slammed like that. Let's have this just control direction as well. Boom, boom, boom. So, there we get some noise field. It's a pretty good size. Now you can do all different other kinds of tricks with this, like based on the color, you can use it to control the magnitude of the vector. But yeah, this is just a really simple example. So let's call this 3D noise field. Now, of course, we're going to go ahead and always save our black boxes wherever they are. We'll just go ahead and put it here for now. Save our black box so that this doesn't use any group, so we can say none. And so now it's very easy for us to, of course, just drop in that 3D noise field wherever we need it. And the nice thing is, it always remembers the textures that we had applied. Those get carried along with TP. So that's it. It's really easy to create a 3D noise field. Don't really need a developer to make one for you, but maybe the developer could add other features. Think about the developer making it excuse me, versus you is, if the developer makes it, you are reliant on them to give you all the features that you want. Nice thing about thinking particles is it gives us all the subcomponents here in order to build the system the way that you want it. So kind of an important distinction. And of course, all these subcomponents in TP that we've used here are all native operators in TP, so they're C++, so they're nice and fast. You can even, use a bunch of script operators that you've have made. They're going to be a little bit slower due to processing, but I think it's always better to have the functionality and have it run a little slow than to not have the functionality and not be able to do something at all. So, enough of the soapbox. There's 3D noise. All right, have a good day.